Alright, so this is a little bit of a pain, and I'm a little bit unhappy with my solution because it's not really too fast. It takes 4 seconds, and not too happy with that, but gets it done, and I think it's a fairly understandable solution, so let's go ahead and do that. So first things first, I'm assuming you've read the question, let's go ahead and create our grid. And again, I'm using complex numbers just because I'm quirky like that and I enjoy them. So let's go ahead here, and we're going to create our grid object as a dictionary for y in row, in enumerate input dot split lines for x value in enumerate our row. And then here I'm just going to add everything to it. And honestly, like, other than the code being a little bit cleaner with imaginary numbers, it's slower to do this as a dictionary than a 2D list. But I think it makes the code a lot easier to read and a lot easier to write, so I still went ahead and did it. So here, we save everything to our grid, and then yeah. And then, so what we're going to do for kind of all of the parts is we're going to go ahead and create a score function, which is going to take our grid, some entry point, and some direction that we're currently going in. And so the way that I kind of handled all of this stuff was I used, first of all, so something called a default dictionary. It's something from the collections class, which is pretty useful for default dict. Let me just go ahead and make sure. Oh, I need to add a line here. I just want to make sure I'm importing this right. No typos yet. Cool. All right. Collections is a STL here, Python collections here. This thing which has these things and is actually incredibly useful. So yeah, thing we're going to be using, we've used counter before, but we're using default dict, which is basically a dictionary where whenever we try to access something, if it doesn't exist, it creates it for us. So it's kind of like other languages, but you'll see why it's kind of useful in a second. But here, so we're going to basically make something for caching, which is going to be a default. It's basically a dictionary which contain lists. So if I do, like, for example here, if I do grid at like ABC or something, it's going to throw some error, and we can probably actually see this here. Yeah, so we get some exception because this doesn't exist in here. If this is the default dictionary, it creates a new list at that location. So then it has some value always. So now with this, basically, this is going to save our states and then what direction we've been at, just so we can avoid loops. And also just kind of keeps our code faster. So here, we're going to have basically a list of beams, because our beams could be splitting. So it'll, each beam will be an entry, or like its position and its direction, like this. So now we'll do, while we have beams, we'll do new beams, because we're basically going to copy them over. And then for position and direction of each beam, we'll do if, first of all, so if P is not in grid, so this is one benefit of storing every point. If it's not in the grid, we just don't care about it. We don't even like worry about it. And then, or if D in seen at position. So seen at position should store all the directions we've been at before at that location. So if I've been going to the left already and I see it in this dictionary, that means I'm in a loop and it's fine. So we'll just skip it. So we'll continue, which goes to the next loop here. And then here, what I'll do is seen P dot append D. So basically say, all right, so if I haven't seen it before and it's a valid input, let me add this to basically the list of things I've already seen. So I've seen at this position, this direction. Now the nice thing is I can just call dot append, because if seen does not, or it doesn't exist like this thing, it'll automatically make a list for me. So I don't need to worry about that being like a, oh, calling this on nothing, or some index out of bounds error, whatever. So now in here, we basically want to have something like if grid P in like something which will give me all the straight directions, then I want to go ahead and like do something like new beams dot append. Here, I'll just write this code and explain a little bit. The way I kind of chunk this is I wrote this for three things: get straight, get clockwise, and get counterclockwise. And like this will make a little bit more sense in a second. But here, basically, we see what the logic should do. Based on that, we add this to our list of new beams. And then finally, we'll go ahead and set that as our beams list. And so here, new beams, if we're supposed to go straight, we just keep going in the direction we're currently going in. So let's go ahead and actually write this function here. So this part is a little bit messy code. I personally would probably write it differently, but this I think makes it readable. and easy to debug. So here, basically these should be all of the characters as a string that you would go straight on. So first of all, if we have a period, we should go straight. And so that's clear. And then now the other two cases is if we are going vertical. So if d.real is equal to 0, because remember we're using the real part of the complex number to represent the x value and the imaginary part to represent the y value. So if the x value of the direction is 0, then that means if I see this vertical bar, that means if I'm going vertically and I see this vertical bar, keep going straight. And then similarly, elif, just to kind of save some time, but if the imaginary value is 0, so the y value is 0, then if I see this horizontal bar, then we're fine. So this gives me all of my straight values. So if I go ahead here and actually just, I'll do return len. So finally, also to get the number of energized squares, which is like this whole thing, all we do is we just return how many elements we've seen. So if I just go ahead and right now just call score grid, and I enter at the top left, which is 0, and I enter facing to the right. Let's see what happens when I call this. Oh, what exception am I getting? Get straight, get straight. Oh, get straights. All right, here. So we're getting currently 2. And this kind of makes sense because if I look at this test case, here I get one value here. Then I get to here because I add the direction and process it. And then I process this, except this is no longer straight, so I don't add a new beam. Beams is now an empty list. This stops, and then my code finishes. So now let's handle all the other cases. So if grid.p, or I'll just copy all of this over. So this should be for get counterclockwise. So get counterclockwise. So here, first of all, if I'm turning counterclockwise, so we should be basically turning, like going to the right should be turned vertical. The problem is our y values are flipped because the top row is, this is 0, this is like 10 or whatever based on how we just read inputs. So we're basically turning from 1 to negative I. And so the way we can do that is we just multiply by negative I. So new direction is equal to d, or let's do, so we did counterclockwise here, so we'll do d times negative 1j. And then all we have to do here, which is nice, is new direction, new direction. And then we can also just directly go ahead and add the code here for clockwise, which is nice, because now that's it. So now we just need to implement these two functions, which is not too bad. So def get clockwise direction. And so what we should do here for clockwise at least is these are the ones where it should turn, like if I'm looking just at this, which ones should make me turn clockwise, like visually me looking at it. I already accounted for the flip here, so I don't need to worry about that. So for me to turn clockwise, the simple cases are like, for example, this slash. If I'm coming at it from the right, I should turn down. If I'm coming at it from the left facing right, I should turn down. If I'm coming facing left, I should turn up. And if you think about it, those are like the only real cases other than this one, where if I'm going down, I should turn right. If I'm going up, I should turn right, or turn clockwise. Yeah. So for clockwise, let's go ahead and write that. So for get clockwise, period doesn't count this time, so let's get rid of that. But if d.real, so we're going vertical. If we are going vertical, then our out should include this. So if I'm going vertical, I should go clockwise because I hit this, bing, go to the right. Hit this, bing, go to the left. And then also, one little cheeky thing I can do is I can also add in this little splitter, because if I hit this, I should go to the right, but I should also have a beam going to the left. So we'll add this for both clockwise and counterclockwise. So now we'll go ahead here, and then we'll just do elif here, and then imaginary, and then now it's kind of clear, we just do the opposite, which is nice, and then now we return this. And then here, we'll go ahead, and we'll return our counterclockwise. So counterclockwise, I'm pretty sure we can just swap. Now that I think about this. No, we cannot. All right. So for counterclockwise, so the reason why is, first of all, if we see this little horizontal bar and I'm going vertically because my x value is 0, I should still go counterclockwise. So we instead just change this. And here, we'll change this into this one. So now if we just double check this, let's look at this. So if I'm going and my y value is 0, meaning I'm horizontal, then if I hit this like this, I should go down. If I hit this from the left, I should go up. All right, so now we have all of that. Let's go ahead and just see what happens if we run it. Boom, 46. And so if I submit this, part 1 is done. Cool. All right, for part 2, we basically just need to see what direction, like what beam from any position gives me the best value if I start there. And so to do this, all I have to do is I'll set P2 is equal to 0, because 0 is a minimum. And then now I'll do for I in range shape, and shape should be basically the shape of my input. So shape is equal to input, or len input dot split lines. And if you notice, your input in the test cases are all a square, so I'm just making that assumption. But here, so what I should do is P2 is equal to the max of P2, and then I'm doing a little trick here where I can take the max from multiple elements. And so I want to see score.grid. And so this here, we basically have like 4 cases. Let me write one down and I'll kind of explain it. So if I have something like this, my I is going from 0 up to shape. So if shape was 10, like for example, for like this kind of test case, then I want to have one beam coming from the left going to the right for each of these values. I want one going from the right for each of these values. I want one going down and one going up. And so here, this one is saying, create me a start point at x is equal to whatever my like thing I'm iterating over is. Y value is 0, and I should be going straight down. And so now, this is the case where I am going from the top to the bottom. Now let's do one from, I'm going from the bottom to the top. So we'll change this here to shape -1 because this is out of bounds otherwise. And this should be going in the negative direction. And then now, we'll go ahead and do one where I am, for my y value is iterating, and I'm starting at x is equal to 0, and I'm going to the right. And then I have one also where this is equal to shape -1, and this is going to the left. And now, let's go ahead and just return this, and let's see what we get. 51, that's a great thing. If I go ahead and submit it, after about 4 seconds, boom, we get the right answer.